Okay, so for this problem, we're going to be doing number 2 of the vector problems that we worked today. And this one involves someone going on a 3-day journey. So there's 3 different directions that he goes. And just like before, I'll show you first with the protractor method how to solve this. I've got a protractor, a nice sharp pencil, and that's pretty much all you need for the protractor method. You might want to have an extra, a longer straight edge. It doesn't have to be a ruler, it could just be some sort of straight edge if the final resultant is a little longer than the protractor. And then once we do the protractor version, I'll show you how to calculate it with a little simple calculator. It does take a little bit more time to do the calculations, but it is beneficial if you want to do something like engineering. Engineering requires us to be very precise in our calculations for safety reasons and all sorts of things. First thing, again, with this protractor method, it's a good idea to have some sort of sketch of the situation. Right? Sketch the situation first. That way you know where to start out your paper and your picture so that you don't go off the page. So, let's see, how do I want to do this one? So, Kita left camp 3 days ago on a journey into the jungle. The 3 days of his journey can be described by displacement, which is a distance and a direction, and it's a vector. The first day he went 40 kilometers at an angle 20 degrees north of east. On the second day he encountered a ravine, so he walked 30 kilometers north before he could cross it, and on the third day he walked 20 kilometers at an angle of 20 degrees east of north. What is the resultant displacement? And remember, even if it doesn't remind you about what a displacement should have, you should already know that you're going to calculate the magnitude and direction of Kita's journey. Notice, there's a reason why I put this in bold, right? North of east and east of north, even though they sound the same and even though they're in the same general direction on a map, they're both northeast, they get 2 very different places. So let's draw a sketch first. So first day, he went 40 kilometers at an angle of 20 degrees north of east. So if he starts over here somewhere, this is north, this is east, so we know he's going in this direction. You can always tell what quadrant of like your compass your person is going in, or your object or your plane or whatever, by the 2 words in it. If it's north and east, then you know you're going in this direction. Same thing here, it's east and north. So we're still going in the same quadrant. So, north of east. This of east is the important starting point. Just like if I was left of the table, first I have to know where the table is in order to know where left is, right? If I'm in between 2 tables, I am left of the table. Well, which table am I to the left of? Right? So that's important. Or if I'm north of Houston, I have to know where Houston is in order to know where north of Houston is. So same thing here. We are north of east. So of east tells us our starting axis, and then we go north of it. So this is going to be, and this is just a sketch, so I'm not measuring, I'm just sketching it out. This is 20 degrees, and he goes 40 kilometers. On the second day, he encounters a ravine, and he walks 30 kilometers north. So So that one's easy. Just north, 30 kilometers. And then on the third day, he goes 20 kilometers at an angle of 20 degrees east of north. Now this 20 degrees threw a lot of students off, right? You see 20 degrees, and you're like, I'm good to go. That is the same angle. Nope. Different angle. Because east of north means we're starting from our north. So we draw another north, south, east, west where he is right now. So he's going this way, 20 degrees and 20 kilometers. So this is east of north. Of north tells us we're using our north axis as our starting point, and then we're going east of it 20 degrees. If we had gone this way, this would be west of north. So let me, just in case, this is still a little confusing, north, south, east, west. Some different angles. This one was north of east. This one, if we measure from that way, is east of north. This one, we've gone to the west of north. So this is west of north. This one would be north of west, south of west. This one is west of south. This one is, now we've gone to the east of south, but we started at south, so this is east of south, and this is south of east. Okay? So that, it does take a little bit of getting used to, but hopefully that little picture helps. Okay. So we got our little sketch. We know he goes in general that direction, and we are going to be looking for like that displacement. So we know we can start our picture kind of in the corner, like the bottom left hand corner of our page, and then we can go this way. Now, what do we want our scale to be? So we have 40, 30, 20. You could use something like I want to use centimeters, simply because if I know that if I use inches, the way inches are divided is not pretty. It's very useful for older, like, ye olden days, right, when you had to divide things in half, and then half, and then half, and then half. So it was useful at a certain point in time, but centimeters is a little bit more useful now because we have 0.1, 0.2, 0.3, 0.4, 0.5. Whereas this is 1/16, 1/8, 3/16, 1/4, right? And I don't know off the top of my head all of those, what those fractions are in decimals. So I am going to use centimeters for this example simply because I don't want to do fractions for those. But I want my 40 kilometers to be as far as I can get all at once. So I'm going to say 40 kilometers is 10 centimeters, or that also means 4 kilometers is 1 centimeter. That's going to be interesting for the 30 and the 20, but it won't be so bad. So start down here, right in the corner. So Same thing, first thing we're going to do is make sure we know what angle we're going at. And this was 20 degrees. So 20 degrees north of east. So there's 20 degrees. Make a line. And make a nice long line, and we'll cut it shorter later when we measure. So, and I'm doing it first in pencil, and then I'm going to go over it in pen so that it shows up better on the camera. But I strongly recommend doing all of your physics work in pencil. Don't use pen unless you absolutely have to, like that's the only writing instrument in your house. I strongly recommend using pencil first. Okay. I'm using pen so it shows up on the camera better. So we know this is 20 degrees, and this is 40 kilometers. I'm going to label it in kilometers. Notice this does not end up nicely on any of our grids, but that's okay, because the grids are mostly there just to help us keep everything nice and straight and parallel. Because now we need to go straight up. How do I want to do this? We need to go straight up, and how far up do we need to go? So if 40 kilometers is 1 centimeter, is 10 centimeters, that means 4 kilometers is 1 centimeter. So we need to divide 30 divided by 4. So 30 kilometers is going to be 7.5 centimeters. So keep your scale in mind, especially if you're trying to make it big. And like I said, drawing it bigger is usually better, because then you can be more accurate. Alright, so from here, and like I said, so these blue lines in between are mostly to make sure I'm staying parallel with everything, so I know that I am going straight up, and I need to go 7.5 centimeters. So keep your scale in mind. So 1, 2, 3, 4, 5, 6, 7.5. And I can do this one right in pen. And that's 30 kilometers. Now the next one, like I said, he now goes 20 kilometers at an angle of 20 degrees east of north. So of north is straight up, and again we're not quite ending on that, so we kind of have to be careful when we're lining up our protractor. Got to make sure everything is kind of like parallel and perpendicular in the way it should be. So, and actually having my protractor oriented this way is not the most useful this time. We should orient it this way. So the end of where we were goes on the point, the bullseye of the protractor. This 90 should be nicely the same distance here as it is here and is here, and that's good. And then 20 degrees east of north is there. And again, I'm going to draw a nice long line in pencil, and then I'm going to go over it again in pen so that it shows up on the camera. And now we gotta measure, so 20 kilometers should be how many centimeters? So we need to divide by 4 again. 20 divided by 4 is 5. So there should be 5 centimeters. So this is why I said it might be good to have a straight edge that's a little longer than the protractor. But again, you don't need something super fancy. If you have the edge of a binder, like even the edge of another piece of paper could work. It doesn't have to be fancy. I'm going to be fancy just for a little bit. Okay. So make sure your starting point is lined up and your ending point is lined up. So that is our resultant. Or sometimes it's, let me see, what does this question say? This one calls it the resultant displacement. But so remember, resultant is just the result of adding vectors. So we have 3 vectors that we added together. The resultant is our start to finish straight line. So, and especially if we are adding displacements, right, distances, then we can call this the resultant displacement. Okay. So the next step is, for the protractor method, is to measure. So we have, there's 10 centimeters. And then we have, it looks like 19. It's ending right at 19. So this is 19 centimeters. But 19 centimeters, we used a funny scale. So now we have to multiply by 4. So 19 times 4 is 76 kilometers. Okay, so our magnitude of the displacement is 76 kilometers. We also need a direction. And like I said, I'm going to try to be fairly standard and go from the horizontal for all of the multiple choice for this year. So for this year with the multiple choice, go ahead and measure from the horizontal. So remember, this was our horizontal, and measure up from there. So this looks like it's just shy of 55. So it looks like our angle is going to be really close to 55, probably 49 point something. So this is 55 degrees, and this is also north of east. Okay, so that took us, even with all the explanation and the introduction and the sketch, that took us 18 minutes. And now we'll see how to do that with calculations. So same thing, first step, draw a picture. Well, in this case, we have the picture already drawn. Second step, make right triangles. And the way you make right triangles is by extending some horizontal lines and vertical lines. So in this case, we have, and that's for anything that's at an angle. We don't need to do anything for this 30 kilometers because it's going straight up. We don't need to find any horizontal component because it has no horizontal component. It is only vertical. It's only in our north direction. But we do need to extend some lines horizontally for this one this one and for this one. And then we need one more big right triangle, and I'm going to draw that. Where do I want to draw it? I'm going to draw it here. There's a couple, you could draw the right triangle in two places for the big one. You could draw it coming this way, or you could draw it going this way. I'm going to draw it going this way simply because I think that might be a little easier to see, and there might be some stuff that gets in the way as we go through our calculations. I might still have to put some calculations on the inside of this triangle, we'll see. I'll try to fit it all on one page. Okay, so now we've got our right triangles. Third step, just like before, is calculate the components. Calculate the components. Why can't I see everything on my page? Make this a little bigger. There we go. That's better. Okay. So we're going to calculate the components of this and this. So let's give these guys some names just like we did before. So I'm going to call this A, this one's going to be B, this one's going to be C, this one's our resultant, so it's going to be called R. Okay, so that means this one here, horizontal is the X direction, so this is AX, this is going to be AY. B does not have any components this time. B is just straight up. C has CX and CY. Oh, and I forgot to label this. Let's label this. This is 20 degrees. Okay. So let's calculate those components. From the first question that we did, we have the adjacent side equals the hypotenuse times cosine of the angle, and we have the opposite side equals the hypotenuse times sine of the angle. So I derived those for the first one. I'm not going to do it again just to save a little time. So let's do AX and AY. First, we have to figure out which one is our adjacent side and which one is our opposite side. So here's our angle. Opposite side goes through the middle of the triangle all the way to the other side. So AY is our opposite side, so I'm going to put AY over here. And AX is adjacent to this angle because cosine is cozy, and it's going to wrap up our angle between the hypotenuse and the adjacent side. So the adjacent side and the hypotenuse are going to wrap up our angle and make it nice and cozy. So we have AX as our adjacent side. Our hypotenuse is A times cosine of the angle. So if we calculate AX, we have 40 cosine of 20. Which should be bigger, AY or AX? And which one, and should they be like significantly bigger or smaller than one another, or should they be similar? In this case, AY and AX should be fairly different from each other. AY should be smaller and AX should be bigger. So let's calculate that and make sure it works. Again, like any time you use sine, cosine, or tangent, it's good to double check the mode of your calculator. In a lot of math classes, you'll be using radian mode often, especially if it's in pre-cal or calculus. But if you're in physics, most often we're using degree mode. So make sure that you know how to switch the mode on your calculator. On a TI-84, there's a button called mode. On a, if you have a smartphone, there's usually a button somewhere that has radians and degrees. And on this calculator, there's a button up here that changes degrees to radians. So this is in degree mode. On the TI Inspire, you can use, there's a little touchpad and you scroll up to the top, and it also has an indicator at the top, and it's really simple. You just click on the indicator. And remember, if you're using either a scientific calculator like this or a phone calculator, you're going to have to do this backwards rather than forwards. So you have to start with 20 and then cosine and then 40. So 20 cosine times 40 equals 37.5877. Keep a lot of decimals until the very end. If you're doing the calculator method, the calculation method, that way you have a very accurate answer and you don't have any rounding error. AY is going to be the hypotenuse, which was A times sine of the angle. So we have 40 sine 20. And again, because these equations and plugging these into the calculator is so similar, it's good to have an estimate of which one's going to be bigger, which one's going to be smaller. Also, if you're in, it'll also help you figure out, did I press sine instead of cosine or cosine instead of sine? It'll also help you if you're not in degree mode, because if you think this should be positive, but you're having a negative number come out of your calculator, that probably means that you pressed, that you're in degree mode rather than radian mode. This is 13.6808. So I'm going to write these down here in my picture so that I don't lose track of them. 37.5877. And this one is 13.6808. We have some more components to calculate. So we need to calculate CY and CY and CX. Now, like I said before in the previous problem, sometimes cosine doesn't go with the x component. It depends on what angle we're given, and in physics we can have a vertical angle or an angle measured from a vertical axis. So first thing we need to figure out is which angle corresponds to this 20 degrees. You can also do, change up the angle. If you don't want to use 20, that's fine. You could use 70, right? This has to be a 90-degree angle because this is horizontal and this is vertical. So 20 plus 70 is 90 degrees. So you could use this 70-degree angle if you wanted. I like to use the angles that I was given because any time that I'm relying on my own calculations and my own estimates, I could go wrong somewhere, right? So I like to figure out, okay, where does that 20-degree angle fit into my triangle? And, where do I want to draw it? And like I said in the other problem as well, if we have two parallel lines, and they're cut by a third line that's not parallel, then any angle that makes a Z has the same angle, right? So here we have a Z, so this angle is also 20 degrees. So I'm going to use the 20 degrees to calculate CY and CX. Which one's the adjacent side now? The adjacent side makes the angle cozy with the hypotenuse. So if this is our angle, it's going to be cozy with CY. So CY is our adjacent side this time. So CY equals the hypotenuse, and in this case, the hypotenuse is C, which was 20, times, and this is cosine, so I kept it on this side so that we have the cosines together. Cosine of the angle. I wanted you to see that the cosine can be used for a vertical component depending on what angle we're given. So 20 cosine 20, 20 cosine 20. Remember, I'm even though it's the same back and forth, on this calculator I'm going backwards. 20 cosine times 20. 18.7938. This is another reason why estimating these is good, because CY, by our picture, CY should be pretty close to 20. It should be closer to 20 than CX is. And 18.79 is pretty close to 20. CX is going to be C sine theta. So we have 20 sine 20. 20 sine times 20 equals 6.8404. Now, we do have to be, now that we've got all these components calculated, we do have to be careful when adding up the components. So this component plus this component. So we do have to add all the x's together, even though I wrote them on different sides of my paper. And then for the vertical components, AY plus CY, but we can't forget B is there too. So even though we didn't calculate any components for B, it still contributes to our vertical displacement. So our x is going to be AX plus CX AX is 37.5877. CX is 6.8404. I keep a lot more decimals while I'm doing calculations so that I don't get any rounding error. So plus 37.5877. So this is 44.428 kilometers. Our y is AY plus B, don't forget about B, plus CY. And these are all added together, unlike the first problem, because these are all in the same direction. So this component and this component are in the same direction. They're east. this component is north, this is north, this component is also north. In the first one we had there was a little bit that went back, so we had to subtract one of the components because it was going the opposite direction. And whenever we have something going in an opposite direction, it needs to be negative. So AY is 13.6808, B is 30, CY is 18.7938, 13 plus 30 plus 18.7938. So this is 62.4746 kilometers. Almost done. We're almost done with the major part of the calculations. Now we just have to have R is the square root of Rx plus Ry. This is the same as a squared plus b squared equals c squared, but I've just replaced, instead of a, I have Rx. Oops. There we go, that's better. A is Rx, B is Ry, C is R, and then to get the just C or just R, take the square root of both sides. So we have 44.428 squared plus 62.4746 squared, and we'll take the whole square root of that. Square that. I'm going to do it the slow way this time. 3903.075076 plus, let's see if I can get this to do it right. So plus, I want all of that squared, parentheses, 44.428 squared, and parentheses, enter. So all of that should be 5,876.2. Take the square root. 76.66 kilometers. What did we calculate it to be? 76 kilometers. So, but if you're doing the calculation method, you're not done yet. You're almost done. So close. What else do we need to find? We found the magnitude, the size, the length of this displacement. We still need to find the direction, because a displacement is a vector, which means it has a magnitude and a direction. And like I said in the previous video, when you're finding the direction, so I like to use cosine and sine for components, and then for directions I like to use the inverse tangent of the opposite side divided by the adjacent side. If you're measuring the angle from the horizontal, the opposite side is the y side. So we'll have tangent, inverse tangent is the opposite side, and the opposite side would be the y component of r, so 62.4746 divided by the adjacent side, which would be the x component of r in this case, 4.428. And like I said, because this is just a kind of a in-between calculator, it's not a baby calculator, but it's not the graphing calculators, this works backwards, so we have to do this inside part first. 62.4746 divided by 44.428. So we get that. Inverse tangent, second tan 54.58, which is still pretty darn close. Okay, so if you have any questions, make sure you ask. That's the benefit of having a teacher. So this whole problem took us, this one went a little faster. It took us 40 minutes. It took us like 20 minutes with an introductory explanation on how to do what things you need in the sketch, and then it took another 20 minutes to do the calculations. Both ways get faster as you practice, so make sure you practice. But I do think that the Protractor version is really the way to go.